Hello viewers, in this session we are going to discuss about an interesting topic, that is effects of radiation on seed germination. So let's get started. Friends, have a look at the screen. In this session we are going to discuss about what is radiation, what is germination, and what are the effects of radiation on seed germination. Friends, have a look at the screen. As history plays a major role in the life. If we look at the history of Japan, we could remember three words. They are Hiroshima, Nagasaki, and the atom bomb. When the atom bomb was dropped in Hiroshima and Nagasaki, it completely killed the lives of the people. And in the nuclear explosion, radiation plays a major role, and it also killed lakhs of people. As it affected the lives of people, don't you think that it also affected the plant life? Of course, it affected, and because of that effect, even the Hiroshima and Nagasaki places are not suitable for seed germination. So today, in this present situation, every country is capable of nuclear charge. So there is a chance to repeat the history again in the future. So we should be bold and we should be ready to face the consequences in the future. For this, it is very important for us to learn the effects of radiation on seed germination. First, let us discuss what exactly the radiation germination means. Friends, have a look at the screen. In this screen, you can see the different stages of the germination. The germinations mean nothing but a development of a small plant. Development of a small plant from a seed is something called as germination. So at the first kind, you can see a seed develops a part called radicle, and that radicle grows downwards called as root system, and that radicle grows upwards called as shoot system. Between the root system and the shoot system, we can see something called as cotyledon. The upper part of cotyledon is called as epicotyle, and the lower part of the cotyledon is called as hypocotyle. So these are the many changes which takes place during a seed germination. So now, as seed germination is a wonderful and very complex process, thus there are some factors which influence the seed germination. So now let us have a look what are the factors which influence the seed germination. Friends, have a look at the screen. Here you can see two different kind of factors. One is abiotic factors and the biotic factors. Abiotic factors which include external factors, which include factors like light, temperature, oxygen, and the soil type or soil fertility. As we all know, light plays an important role in the process of photosynthesis. During a seed germination, light plays an important role for the embryo development, whereas temperature also plays an important role for the seed germination. The approximate temperature from 25 degrees Celsius to the 30 degrees Celsius is a need for every plant to germinate. And next comes oxygen, as oxygen is very important for the metabolic activities of a seed. Thus, the oxygen is also very important aspect for the seed germination. And next is soil nutrition, as soil nutrition is very important, because if the soil nutrition is good, then the seed can get minerals, water, and many kind of nutrition from the soil, and it can develop properly. Thus, soil also is very important aspect. So these are the external factors. And once if you look at the internal factors, which include factors like viability of seed and dormancy period. What does it mean, the viability of seed? It means the ability of the embryo to develop is something called as viability of seed. Then what does it mean, dormancy period? Dormancy period is nothing but where for permanent period the cell division and the seed germination is stopped. So these are the internal and external factors of the seed germination. Don't you think there are other factors which also influence the seed germination? Of course they are. Among the radiation is the first. Friends, have a look at the screen. First, let us discuss what this radiation means. Radiation is a form of energy which transforms from one place to the other place in the form of waves. So in a day-to-day life, we can see natural radiation and the artificial radiation. Thus, it is very important for us to notice that every organism in this world is exposed to radiation. Radiation consists of different kind of rays, different kind of wavelengths, and based on the wavelengths and the energy, these rays are arranged in the form called electromagnetic spectrum. If you look at the screen, you can see here the electromagnetic spectrum, which consists of rays from low radio waves to the higher gamma rays. These radio waves consist of 10 power 5 meters of wavelength. here the wavelength is more, so the energy is less. If you look at the gamma rays where the energy is less, that means 10 power minus 13. Here the energy is less and the energy is high and the wavelength is low. And between, in our way from radio waves to the gamma rays, we could find something called as visible light. We could see the visible light in the form of rainbows, and in our day-to-day life we are well exposed to visible light. So after in this electromagnetic spectrum there are two kinds. Below the visible light, this part is called as non-ionizing radiations, and above the visible light, here you can see these kind of rays are called as ionizing radiations. Ionizing radiations are much more energy than the visible light, and these non-ionizing have less energy. As we all know, this visible light influences the process of seed germination, but don't you think that the rays above the visible light, which have much energy than the visible light, also influence the seed germination? Of course they will influence. So now let us have a look at every kind of ionizing radiation, which include UV rays, X-rays and the gamma rays. So how they are influencing the seed germination. Okay friends, let's get started. So far we have seen what is germination and what is radiation and what are the factors for the germination process. Well and good, but here my question is that what is the need to study this aspect? What is the need? What is the future need of this studying this aspect? It means, as we all know, in this world there are many pollutions like air pollution, water pollution and different environmental pollutions which are causing the global warming, and pretty certainly the radiation is one among them, which is increasing day to day due to the mankind activities. Thus it is very important for us to do research and to learn the effects of this radiation on seed germination. When I started doing this research, I could find only few institutions are working on this, and I have collected the data from different institutions, and now I am going to present you. So to present in front of you, I have followed some data which includes many parameters. The parameters like I have collected the data from different institutions, I have collected the data from different geographical conditions, and I also collected the data from different variety of same plants. Now let us have a look at the first kind of ionizing radiation, that is UV radiation. Friends, have a look at the screen. This is UV radiation. If you look at the navigation of UV radiation which comes after the visible light, so these UV rays have much energy than the visible light and has less energy than the X-rays and the gamma rays. So we all know that sun is the biggest source of this UV radiation. These are the fundamental properties of the UV rays. Then how we are using these UV rays in our day-to-day life? Come, let us have a look at it. Friends, look at the screen. Here you can see the different kind of applications of these UV rays. The first kind we use is for welding of iron, and the second type is for using these UV rays are used in a laboratory purpose for the sterilization of germs, and it also in biological purpose these UV rays are useful for mutational breeding also. Done. So these are the applications of UV radiations. Then what are the effects of this UV radiation on seed germination? For this I am going to present you two case studies. First let us have a case study 1. Friends, look at the screen please. So here this experiment was done by taking the Vigna mungo seed, which is commonly called as black gram, and this experiment was done in Pakistan. If we look at the result of this experiment, it shows that at zero level, at control level where there is no radiation, you can see the germination percentage is almost 94.7%, and at when the radiation dose increased to 10 minutes, there you can see the germination percentage also decreased from 94.7% to 89.5%. As we go on increasing the radiation percentage, you could see the germination is also decreasing, and at 40 minutes where we given 40 minutes radiation, the germination percentage is just 70.5%. Thus we can say that this UV radiation is showing much effect on the germination of black gram, and this is the story of the germination percentage. If you look at the speed of the germination, where at zero level, at control level where there is no radiation, the germination percentage the germination percentage is almost 28.4 percentage. As we go on increasing the radiation dose, there is decrease in the germination speed also. So here we can clearly see that. From this case 1 study, we could conclude that the UV radiation are influencing the germination percentage of black gram seed. So this is the result of case 1. So now let us go and have a look at case study 2. Friends, look at the screen please. And this experiment was done by taking red bean seed, different variety of seeds of red bean seeds, and this experiment was done in Iran. And the two different kind of seeds are, one is SoFTNET and the other one is Direction. So this, the first graph explains the germination percentage and the second graph explains the speed of the germination. First let us have a look at the first graph. Here there are different kind of radiation doses, and here you can see the different percentage of germinations. At 220 nanometers where the energy is more and the germination percentage of SoFTNET seed is continued constant from beginning of this experiment to the end of the experiment. Only in few situations you can see the fluctuations of the germination percentage. Thus we could conclude that this SoFTNET seed is not showing much influence of this radiation. And now look at the screen of Direction seed. If you look at the Direction seed at 220 nanometers where the energy is high, we could see the germination percentage is almost 82 percentage, and as we increase the radiation dose we can see the fluctuations of this germination percentage, and at from 340 nanometers it remained constant. This is how the germination percentage is. And if we have a look at the what is the speed of the germination of black gram, friends, have a look at the screen. So here you can see that at very high energy level both the seeds are showing less, that means few days, 5 days for the germination, but whereas at a lower energy they are taking almost 6 days to germinate. Thus we could say that these UV rays are muchly influenced by this red gram seed, and whereas SoFTNET seed is reluctant to show the germination percentage when it is affected by the UV rays, but whereas Direction seed it is much sensitive towards the UV rays. This is how the so far we have seen what are X-rays, what are the properties of X-rays, and what are the effects of these UV rays on the seed germination. And in further we will look into the what is the next kind of ionizing radiation, and that is X-rays. If we look at friends, have a look at the screen. If we look at the X-rays which comes after next to the UV rays, that means they have much energy than UV rays but have less energy than the gamma rays. So these X-rays are produced when the fast moving electrons are hit or bombard a hard particle, then the X-rays are produced, and these X-rays have much energy, they can even penetrate the wood also. These are the fundamental properties of these X-rays. Now if you look at the applications of these X-rays, you can see here that in our day-to-day life we will use much X-rays in the field, in the clinical field, and also in biological field to know the different structures of unknown molecules. And beginning of 20th century these X-rays were also used in the mutational breedings also. So these are the fundamental properties and fundamental applications of these X-rays. Now let us have a look at what are the effects of this X radiation on seed germination. For this also I am going to present you two case studies. Now let us have a look at the case study number 1. Friends, have a look at the screen. Here for this case study, Echinacea angustifolia, this plant belonged to the sunflower family, and this Echinacea angustifolia seed was taken for this experiment, and this experiment was done in northern part of USA. And if you have a look at the screen you can see the result of this experiment. Have a look at the screen please. So here you can see the different dots which are mingled together. So here there are different kind of radiation doses, that is Roentgen per hours. Roentgen is the units of these X-rays, and here you can see the different kind of radiation doses, and here you can see the different germination percentages. And at zero level where there is no radiation, the germination percentage is almost 82%, and as we go on increasing the radiation dose, the germination of the seed is fluctuating. It is increasing, it is decreasing sometimes, and again it is increasing. Friends, have a look at the screen. At 1200 nanometers of these X-rays, we can see there is a drastic decrease of this germination percentage. Thus, from this experiment, we can clearly conclude that this echinacea seed is not showing much influence, as we know that these dots are not lying just before the above the line and just below the line. That means this seed is not showing much effect of this X radiation, as we seen in the direction seed. And here we could also conclude that at 500 level dose, the germination of this seed is 100%, so that the optimum level dose of this seed to germinate at 100% is 500 radiations. If we give 500 Roentgen's radiations to this echinacea seed, then we can see the good development of this echinacea seed. So this is the result of this case study 1. Now let us have a look at the case study 2. Friends, have a look at the screen, and this experiment was done by taking the palm seed, and this experiment was done in one of the premium institute of Saudi Arabia. And if we have a look at the result of this experiment, here there are different kind of radiation doses, and here you can see the different germination percentages. At 0 level, at control level, where there is no radiation, we could see the germination percentage is almost 95%, and as we go on increasing the radiation dose, we could see there is a drastic decrease of the germination percentage. So here the germination percentage is decreasing steadily. Thus we can say that these X-rays are influencing the germination of this palm seed. So these are the case study 1 and case study 2 results. Now let us have a look at the next level of ionizing radiation, that is gamma rays. Friends, have a look at the screen. These gamma rays comes after the X-rays in an electromagnetic spectrum. That means they have much energy, even more the X-rays and even more the ionizing and non-ionizing radiations. So these are produced when the fast moving electron hits or bombards an electron and a strong electron, and these gamma rays are produced with among the alpha and beta rays. These are the fundamental properties of these gamma rays. Now let us have a look at what are the day-to-day life applications of these gamma rays. Friends, have a look at the screen. You can see here in our day-to-day life these gamma rays are useful in mutational breeding and for sterilization of food and utensils, and also recently the food of Chandrayaan was sterilized by these gamma rays. So these are the fundamental properties and also these applications of these gamma rays. Well and good. Now let us have a look at what are the effects of these gamma rays on the seed germination. For this also I am going to show you different kind of case studies, case study 1 and case study 2. Now let us have a look at case study 1. Now friends, have a look at the screen. For this experiment, a seed called maize was taken, and this experiment was done in Romania. And if we have a look at the experiment of result of this experiment, it shows that there are two different kind of radiation seeds were taken of same maize seed, and the two different kind of seeds are HM4 and HQPM1. So their graph in the graph the first bar shows HM4 and the second bar shows the HQPM1 seed. So here there are different kind of radiation doses, and here the germination percentages. So at the 0 level, at control level, where there is no radiation, we could see the germination percentage of this HM4 is almost 82%, but whereas in coming to the situations of HQPM1, the germination percentage is almost 95%. So as we increase the radiation dose, we could see the fluctuations, increase, decrease of fluctuations of this germination percentage of these both seeds. And here we could clearly say that the 100% germination of HQPM1 can be seen where the radiation dose is almost 0.05. So it is very known that the optimum radiation dose of HQPM1 is 0.05. Now let us have a look at what is the case between HM4. To get the good yielding of HM4 seed, we could give it the radiation dose of 0.4. The optimum radiation dose of this HM4 is the 0.4, kilograms of this radiation. And this is how the case study 1 is. And let us have a look at the case study 2. Friends, have a look at the screen. In this screen, and this experiment was also done by taking the mesh sheet, and here they only taken the mesh sheet. And if we look at the result of this experiment, we can clearly see that as we increase the radiation dose, there is drastic decrease in the germination percentage. That means here the gamma radiation are influencing the mesh sheet germination. This is the result of case study 2. And for this gamma rays, I have another case study to present in front of you. Now let us have a look at it. Friends, have a look at this screen. So this experiment was done in Saudi Arabia, and the same mesh sheet was taken. And if you look at these T1, T2, the T's represent the treatment 1 and treatment 2. At 0 level, at control level, where there is no radiation, we could see a good yielding and good germination of this seed at 87.75 so on percentage. As we increase the radiation dose, we could see the germination percentage is decreasing drastically. So friends, far from we have learned what is germination, what is radiation, and what are the effects of different kind of radiations on the seed germination. Well and good, but here my question is, what is making the seed to develop less? What is causing this radiation to a seed for its germination? Now let us have a look at what is going internally in the cell when this radiation enters into it. So friends, have a look at the screen. If you can see here, as we all know, hormones and enzymes are the building blocks of every organism in this world. Hormones and enzymes are made with of proteins, where proteins are made with of DNA. In this cycle, if something goes wrong, then the entire organism will die. So same principle is followed in the case of this affection. So as friends, when these radiations, whether it may be gamma or X-ray or UV rays, enters into a cell, the main aim of these radiations, radio waves, is to damage the DNA. So to damage the DNA, they follow two cases. Case number 1, have a look at the screen. Case number 1, that is direct wave. When the radiation introduced or enters into a cell, it directly reacts with the nitrogen bases of the DNA, which includes C, A, C, T, G. So with these nitrogen bases, these radiation will react, and after reaction this DNA will get damaged, that is single strand break damage. So if the DNA is damaged, then slowly the proteins which are produced from the DNA are also damaged. If proteins are damaged, slowly the hormones, the enzymes which are required for the seed germination are also damaged. So this is the case study 1. And if you look at the case 2, that is indirect way, have a look at the screen please. So here you can see the indirect way, where the radiation enters into a cell, and again it will react with the water, H2O, as 90% of the cell is consists of water, and after reacting with the water, it will produce different kind of ionizing radiations, that means different kind of free radicals. So these free radicals, which includes OH minus, OH plus, HO, and these free radicals again reacts with the DNA and give double strand breaking. So in the both cases, DNA is getting harmed. So when the DNA is getting harmed, then slowly the proteins and then the hormones and enzymes required for the seed germination are also affected, and this is the case which is happening commonly. So as we all know, gibberellin hormone is very important for the seed germination. So when the DNA is affected, slowly the gibberellin hormone is also affected, where the germination is blocked. So far we have learned what are the effects caused when the radiation enters into a cell. Now it is time to present my observations, my opinions on this research. Friends, have a look at the screen. So after all my research observation, I could find that as we increase the radiation doses, I could find the decreasing of the germination percentage, and also the germination and the radiation effects are differ from one place to other place, from variety of seed to the variety of seed, and from geographical conditions to the geographical conditions. And also the methodology a scientist follows for this experiment also plays a major role to get a good result. So I have applied all my observations to the future perspective. So now let us have a look how my future perspective and my future talk is that. As we seen that the optimum radiation dose for every plant gives a good germination percentage. To know the optimum percentage of every seed, it is very important for us to know and understand the radiation in a proper way. If we understand the multifaceted ways of radiation, then we can apply. So most of in the situations, if we apply the radiation in a wrong way, then there is a chance to get the food scarcity. So it is very important for us to know the different phases of the radiation. And my opinion is that I want nuclear science and the biological science to mix together, because if the nuclear science study the different phases of the radiation and different applications of the radiation, then if it helps the biological science branch to apply them in the crop yielding, then we can see the miracles in the agricultural field. So the need of the hour is to mingle the nuclear technology and the biological science technology. So these are my future perspective. So I thank CREDA institution which helped me a lot for this research, and thank you one and all who helped me directly and indirectly for this presentation. Thank you.